All right, so we are looking at operations on radicals again today. Yesterday, our focus was primarily on multiplying and dividing. Today, our focus is going to be on adding and subtracting. So, in order to add and subtract radicals, it is much like variables. They have to be what we consider like terms. So, you cannot add and subtract radicals unless they are like. So what we're going to do is continue to focus on simplifying a radical. If a radical can be simplified, then you must simplify it. That simplification will allow you to add and subtract them together. So again, radicals can be added and subtracted in the same manner as variables. They must be like terms. To be like terms, they must have the same index, meaning cube roots can be added to cube roots, but cube roots cannot be added to square roots. So same index, and they must have the same value underneath. So you can't add the square root of 2 to the square root of 3. They're not like terms. So oftentimes when adding and subtracting, we don't have very many like terms. So, like versus not like. Is the square root of 3b a like term with 4 square roots of 3b? Do they have the same index? Meaning, are they both square roots? Yes. Is what's underneath the square root the same? Yes. Therefore, like terms. Is the index the same in example 2? Are a square root and a cube root the same? No. So this is a square root, this is a cube root. Therefore, unlike terms. They cannot be added together. Is the square root of 2b a like term to the square root of 3b? Do they have the same index? Yes. Are they like underneath the radicals? Is 2b the same as 3b? No. Unlike terms. So our problems are going to look more like this. And it's just going to say simplify. And you're going to have 4 square roots of 8 being added to 3 square roots of 50. If you look at these right now, are they like terms? No, because you have an 8 and a 50. However, 8 and 50 both can be simplified. The square root of 8 and the square root of 50 both divide by perfect squares. So simplifying with an addition of addition still means we need to do what we've been doing. 4 square roots of 8 needs to be simplified so that if you have 8, like the numbers 4 and 2, because the square root of 4 is 2. So really what that means is that 4 square roots of 8 is equivalent or simplified as 8 square roots of 2. And again, some of you might skip those middle steps and do the math mentally. That's fine. Plus 3 square roots of 50. 50 is the same as 25 and 2, but the square root of 25 is 5. So that becomes 15 square roots of 2. Now, are 8 square roots of 2 and 15 square roots of 2 like terms? They are. So what we do is we add the outside numbers. It'd be like if I told you add 8x and 15x. You would just add 8 and 15 to give me 23x. So 8 square roots of 2 with 15 square roots of 2 becomes 23 square roots of 2. Same thing. Now we just have some subtraction signs in there. But the ultimate goal is to simplify what is underneath those radical values. So 12. Does 12 divide by a perfect square? Everyone shaking your head, yes. 12 divides by 4. The square root of 4 is 2. So then 5 square roots of 12 becomes 5 times 2 square roots of 3. 27 divides by 9. So 9 becomes 3. So you get 2 times 3 square roots of 3. How about 128? Does 128 divide by a perfect square? 64. And the square root of 64 becomes 8. So I have 5 times 2, which is 10 square roots of 3, plus 2 times 6, giving 6 square roots of 3, minus 8 square roots of 2. Does that simplified form contain any like terms? 10 square roots of 3, 6 square roots of 3. Perfect. So what we're going to do is add the 10 and the 6 to get 16 square roots of 3 minus 8 square roots of 2. Very good. Multiplying is pretty easy. The hardest part is remembering to go back to our days of FOIL. So just like you can add and subtract, you can multiply. We multiplied a little bit yesterday. So we introduced multiplying yesterday, just 2 times 2, like a square root times a square root with variables underneath. What makes today a little bit nicer is we really don't talk about these with variables. We really just use numbers. So I think the variables are what kind of trip us up. So I think today is a little bit easier because we're just going to have a number times a number. The only thing again is that the index must be the same. You cannot multiply a cube root by a square root. Like, that's impossible. Cube roots and square roots cannot be multiplied together. So the square root times the self always goes away. That's what you have to remember when multiplying. So we're going to FOIL. We're going to do first. If there is no square root attached to the number, you just multiply the numbers out in front. So 2 times 3 is 6. So you get 6 square roots of 3. That's your first. Then FOIL says outer. You get 2 times -1. But the square root of 3 times the square root of 3, which is what we learned yesterday. If you have the same square root times itself, the square root fades away and it becomes the number 3. So 2 square roots of 3 times -√3 becomes 2 times 3. Enter. Number and number multiply together. No more square root for both terms, so that root 5 just tags along. And then last, a positive times a negative is a negative. 3, the values underneath are different, so you multiply them together. Does this have any like terms? We have a √3, a √5, and a √15. Are they like? No. Since I said, like, sometimes when you multiply, or you're adding and subtracting, there's not a lot of like terms. It's just a really long, messy answer. We would like to clean up this 2 times 3. So I would say 6√3 minus 6 plus 9√5 minus 3√15. That's your answer. Don't overcomplicate. Let's do another one. First, we need to red. So, number times number, inside stuff times inside stuff. 6 times 2 is 3 times 5. Perfect. Outside. Again, number times number. 4 times 6. And 3 times 2. Inside stuff. Number times number. Only a single radical, so it stays. Last. Negative number times positive number gives a negative number. Only one square root. Once again, do I have any like terms? No, you're done. There's not even any numbers that simplified. That's your answer. Multiplying is simply FOILing. Multiplying is simply FOILing. We're not going to do that. So you can just, we're gonna cross off the conjugates, and we're gonna cross off the examples on the next page. Not gonna overcomplicate your lives either. So I'm looking at our homework and make sure I don't need to cross off any of them. Alright, you're gonna stop at 40. You're not gonna do 41, 42, 43, 44. Again, 11 problems. Please show your work. The backs are the foils, the fronts are the adding. Yeah.